Good morning, student. Uh, Today I am going to discuss the numericals based on op-amp, which is most important for your exam. So let's start. Your first question is, for a particular op-amp, the input offset current is 20 nanoampere, while input bias current is 60 nanoampere. So what we have to calculate? These two input bias current. So what we have to do? As we know, input offset current is a difference of input bias current. Okay, so difference of input bias current is equal to 20 here given. Now what? And what is your bias current formula? IB is equal to IB1 plus IB2 upon 2. It is given 60. Here is misprinting. It will be 60. Now IB1 minus IB2, IB1 plus IB2, both you have got. Now by using these two equations, you can calculate IB1 as well as IB2. First you have to add these two equations. You will get, first multiply 2 with 60, then add these two equations. IB2 will be cancelled out, and 2IB1 equal to 140, and then IB1 equal to 70 nanoampere. Put this IB1 value in equation 1, you will get IB2 50 nanoampere. So this is the two first question based on op-amp. It is very simple. Second question, determine the output voltage of an op-amp for a input bias voltage, and there is a input voltage, there is a two input voltage, so V1, Vi1, Vi2 both are given. The op-amp differential gain also given. The value of CMR are there are two value of CMR are given. So according to these data, we have to calculate what value? Output voltage. So we know V naught equal to AD/VD plus AC VC. So we don't have AC value. So what we have to do? We know CMRR. CMRR equal to what? AD upon AC. So AC equal to AD upon AC. Put the value of AC in this equation. So now you have the equation AD/VD plus AD upon CMRR into AC. Now all value you have. So for first CMRR, put the value of CMRR to you 200, and VC equal to, we know average of these two input voltage. Okay, so putting all these value, you will get V naught. First CMRR. For second CMRR value 10 to power 5, same equation, you have to put the data and you will get second output value. Okay, so this question is based on totally on your output equation. Now question number 3, for an input of Vi 50 millivolt in the given circuit, determine the maximum frequency that may be used. Okay, the op-amp slew rate also given. Here you have V input. Okay, you have to calculate what maximum frequency. So slew rate formula we have to apply. Now this is your circuit diagram. V input given. So first calculate V output. So this is a inverting amplifier. The formula of inverting amplifier is V naught equal to minus RF1 R1 into Vi. So all value you have, you can get V output. This is minus 5 volt. Now the magnitude of output is 5 volt. So what is the formula of slew rate? Slew rate is nothing but maximum rate of change of your output. So 5 volt is maximum value. Okay, so you have got Vm. Now F max formula is equal to slew rate upon 2 pi Vm. You have all the values as slew rate as well as Vm. Slew rate as well as Vm. So put the value of slew rate here, 0.4 into 10 to power 6 upon 2 pi. Vm is also given 5 volt. So from this formula you can calculate this value, 12.732 kilohertz. Okay, so the trick of this question is, you have V input, and from this V input you have to calculate V output by using this circuit diagram. After getting V output, then you have to apply V max formula. At least some student will get confused because at the place of Vm they will put the value of input voltage, but this is not correct. You have to put the value of output voltage, maximum output voltage, because this is the definition of slew rate. Now fourth question is, let me minimize this. What is the range of the voltage gain adjustment in the following circuit? You have this circuit diagram. This is circuit diagram of inverting amplifier. So here one resistance has been connected in the series with input resistance, and this resistance has variation from 0 to 10 kilo ohm. Okay. So with this variation we have to calculate your range of voltage gain, because you have range of resistance. So according to this we have to calculate range of voltage gain. So first this is very simple question. First thing what you have to do, first put 0 kilo ohm resistance, then you calculate voltage gain. Second, put 10 kilo ohm resistance, then calculate voltage gain. When 0 kilo ohm you will put, then both 10 kilo ohm and 0 kilo ohm will be in series. So R1 will equal to 10 kilo ohm plus 0 kilo ohm, and RF you have given, then voltage gain formula apply, minus RF upon R1. RF is constant, 500 upon 10 minus 50. First voltage is minus 50. Second, you have to put 10 kilo ohm. So 10 kilo ohm plus 10 kilo ohm become 20 kilo ohm. So then again gain will be minus 500 upon 20. Then you have to get this voltage gain. So this is your range of voltage gain, minus 25 to minus 50. Okay. Now question number 5. Question: for the following circuit, find the closed loop gain output voltage. You have to find two values, closed loop gain as well as output voltage. So this is the totally based on your formula inverting amplifier. Closed loop gain is equal to minus 100 upon 10 kilo ohm, minus 10. Output voltage is equal to closed loop gain into input voltage. So minus 10 into 1 volt, minus 10 volt. Okay. Sorry. Now in question number 6, find V output for the following circuit. So in the class I have also teach you, this is the circuit diagram of adder, and formula of adder is minus RF upon R1 V1 plus RF upon R2 V2 plus RF upon R3 V3. RF is 100 kilo ohm, R1 R2 R3 is given, V1 V2 is also given. Put this value, you will get minus 3.1 volt. Okay. Question number 7, for the following circuit find V0. This is also your adder. Use a formula, you will get answer. Question number 8, find the output voltage for the following circuit. So this is the important question. Be careful for this question. So as we know, according to the virtual short, also known as virtual ground, the voltage of this at this point will be equal to the voltage of at this point. Means inverting non-inverting voltage will be equal to inverting point voltage. So we have to calculate the voltage at point A. So how you will calculate? Just apply KCL at this point. So KCL, what KCL statement? KCL statement is incoming current is equal to outgoing current. So what is the incoming current? The voltage difference upon resistance. Then outgoing current is also voltage difference upon resistance. Voltage difference is 1 volt minus V dash upon 10K equal to V dash minus 0 upon 10. From this equation you have to calculate V dash. So what will be V dash? V dash equal to 0.5 volt. Okay. From the concept of virtual ground, at node B is also 0.5 volt. Means at this point. So now apply KCL at point B as well. What will be the case? What will be the equation? After applying KCL at point B, 2 volt minus 0.5 volt upon 150 equal to 0.5 minus V naught upon 300. Okay. So from this equation you can calculate V naught, which is equal to minus 2.5 volt. Question number 9. What question number 9 tells? Question number 9 tells that this is the equation. Now same equation, you have to calculate V naught here at point A by using KCL. So here 2 incoming current, 2 volt minus 1 volt. Outgoing current only 1. So just apply 2 minus V naught upon 10 minus 1 minus V naught upon 10 equal to V naught upon 10. So after that you can calculate V naught. Same up, this voltage equal to this voltage, then your 0 minus V naught upon 10 equal to V naught minus V dash, not V dash. V dash minus V naught upon 20. And we know V dash equal to 1 by 3, so put this value, you will get V naught. So equation number 8, equation number both are same, just one resistance can be connected in the non-inverting terminal. Question number 10, find the voltage V2 and V3 of the following circuit. So one most important thing you have to understand in this circuit diagram, this first circuit is your inverting terminal is directly connected to your output. So this circuit is known as buffer, or we can say voltage follower. So what input you will apply, that input will be same as output in the voltage follower circuit. So V input equal to 0.52 volt, it will be equal to at point A, and this is directly connected to output, so output is equal to also 2.52 volt. Now here 0.2 volt input applied at both circuit. So first circuit is inverting amplifier, second circuit is non-inverting amplifier. Just apply formula, you will get V2 and V3. For V2, minus RF upon R1 into VI. For V3, 1 plus RF upon R1 into VI. All value you have, you get value. Question number 11. Calculate the output voltage for the following circuit. So this is your inverting amplifier. You can calculate V naught. And now here, this V naught will act as the input for second circuit. And one input also applied. So this is adder. Okay. After getting V naught, you have to apply adder formula for the second circuit. So V naught is equal to minus 120 millivolt. And then for this circuit, V naught is equal to minus RF on R1 per V1. Okay, if you have idea about adder, inverting, non-inverting, then all question is very simple for you. Okay. Now question number 12. For an op-amp, slew rate is given. Okay. What is the maximum closed loop gain that can be used when the input signal varies by it? Here input signal is varying. Slew rate is given. So you have given maximum closed loop gain. So we know slew rate is equal to del V upon del T. Okay. The first formula. Second formula, V naught equal to ACL into VI. Then del V naught is equal to ACL into del VI. Okay. So these del V naught you have to put in the slew rate formula. Okay. When you will put slew rate equal to ACL into del VI upon del T, we have to get ACL. Slew rate is given, del VI is given, delta T is given. Del VI equal to what? Just del VI 0.3 volt and del T 10 microsecond. Put here, micro is 10 to the power minus 6. From here you can calculate closed loop gain, which is equal to 80. So two formula you have to apply. One is the slew rate formula, del V naught upon del T. Second is V naught equal to ACL into VD. So rate change of V naught equal to also ACL into change in V input. Okay. So this is all about today's lecture. This question is totally based on op-amp, and it is very important for your sessional exam. So try this question on your rough many times. Definitely you will get good marks. So thank you so much for being here. All the best.